resultant of the parallel force system shown in the figure and locate the intersection of the line of action with the xy plane. Which problem is it? Force moment, or force location?
Location.
Force location. So Nick, what's the first step?
The result.
Find the resultant force. So what's the force? What's the result? 500, 400, 300, 200. They're all negative. Do they have an axis up here? Yeah, so what is it?
Negative 14.
So sum of the forces in the Z equal 5, 9, 10, 11, 12, 13, 14, 1400, and negative K. And what units? Newtons or pounds?
Newtons.
Okay, the next step, Nicholas? What do I have to find? Okay, so now we have to think about this. So, do these forces create a moment about the z-axis?
No.
Why not?
Parallel.
Parallel. Do they create a moment about the x-axis?
Yeah.
Yes.
Yeah.
Do they create a moment about the y-axis?
Yeah.
Yes. So Nicholas, which axis do you want to work with first?
Wait, doesn't the 200 intersect it?
Yeah, so the 200, great. The 200 intersects the y-axis, so does the 200 create a moment about y?
No.
No. But does it create a moment about x?
Yeah.
Yes. Good point. So let's do it. So which axis do you want to do first? Okay, sum of the moments of the x equals 500 times, you want to use meters or millimeters?
Meter.
Let's use millimeters. Oh, okay. 500? So it's 500 times what?
500.
Right. Positive or negative? Negative. Okay, 400 times? I'm going to keep dividing Nicholas dots, okay. 1,000. Positive, negative? Negative. 300 times?
Of the total distance. Yeah. Right.
1,000. Positive or negative? Negative. 200 times? 1,500. Positive or negative? Negative. What does it come out to be?
Money. It's money, Chelsea. That's a lot of owing. That's a lot of negative money.
Yeah.
School.
That's a PhD debt there.
Okay. I haven't wound up converting it, so let me 1, 2, 5, 0, 1, 2, 3. Newton millimeter. Okay, sum of moments about the y-axis. Jack,
It's 500
Times?
1,000,
positive or negative? Positive,
and then positive 400 times 1,000,
okay.
and positive 300.
Okay, and what do you get as the value? Comes out to be 1,050,000. Could I convert it now? Negative 1250 Newton meter. And negative, nope, positive. 1050 Newton meter. Moment, sum of moments in the y. Sum of moments in the x. Okay, I'm going to use this picture. So here's my y-axis. Here's my x-axis. Here's my z-axis. So Santiago, what's the resultant force?
Negative 1400.
Right, so 1,400 down, right? And then does it create a negative or a positive moment about x, Jason? Negative moment about x, and how about y? Jose? Positive. And we're doing a force location problem, right? So what's the next step? Carolyn, what's the next step after we calculate the resultant force and the resultant moment? Go back to the steps we had. For a force location problem, what's the next step we need to do?
Determine the
Perpendicular distance. So the perpendicular distance we knew was equal to the moment divided by the force, right? So let's think about that. How should we approach this? Why don't you talk to the person next to you and figure out how are you going to approach this? You have a force in the z and you have two moments. How should you go about calculating the distances? Oh, Karen. Thanks. Is Tuesday okay?
Yeah, I gotta talk to Carl, but I'm
Okay.
gonna say it's okay.
Okay, that's right, you have class.
Yeah.
Okay.
We'll join 25 and statics 1.
Yeah.
Oh, it's engineering 5?
Yeah.
Even better. This is what you need.
Do you know what the topic is? You doing it on Tuesday?
Tuesday we're doing distributed loads. Is that
No,
right?
no, I'm sorry, in engineering 5.
Like, how's it doing that in 5?
Engineering education. Carl's gonna do it.
This is
You want to
education.
do it?
I asked him if he'll do it.
Okay. God, you should tape them so I can watch them. That's like my topic.
When I come in this class, will I have to be taped, huh?
No, no. You've taught this 20 times.
Okay.
Okay, so what's the idea? Isaac, you have an idea?
Are we just going to divide the factors?
Well, do you want to put them together? Do you want to separate them? Think about, remember the next step, what's step 4? In a force location problem, first step is find the resultant force, find the resultant moment, do the perpendicular
We're dividing
distance.
magnitude,
What's,
so we get the magnitude of each vector.
okay, hang on a second. What's this fourth step?
Fourth step,
Yeah,
drawing the
it's
plot.
to draw it, right? So let's kind of jump to the fourth step for a minute. We know we're going to have 1,400 going down somewhere, right? But we don't know where we're going to have it drawn. So does that help you think, when you see it visually, does it help you think about how you should do the calculations for the perpendicular distance? And think about, remember the moment is equal to r cross f, right? And remember the definition of this gives you a perpendicular, right? The definition of the cross product, it gives you a vector that's perpendicular to these. We already know that the force is in the z, right?
Yes.
Okay, so I'm trying to give you hints. Isak, you want to try again? And you may have said the answer, I just didn't understand how you were saying it. Show me what math you would do.
I mean, are we just finding the magnitudes of vectors? I'm not sure what you mean by using the
Okay.
cross product now.
Well, the only reason why I'm introducing, we're not doing the cross product. I just want to remind you, remember when we said if the force is z and the moment is x, the distance is y, right? If the force is z and the moment is y, the distance is x. So have that as a reminder, and maybe that'll clue you into what kind of calc we want to do here. Sam, do you want to?
Would you do the x and y separately?
Yes.
Okay.
Okay, and maybe that's what you meant, Isak, I'm just not sure.
I'm not
Okay,
sure.
so how would you do it then, Sam? You would do the moment of,
1250.
okay, hang on, let's put the variables in. So you would take the moment in the x divided by the force, which we know it's the z, right?
Yeah.
And what would it give us? What distance would it give us? Y. So look at this, because this is where a lot of people make mistakes. It gets confusing. We're putting the moment in the x, we're dividing it by the force in the z. So the distance, I'm getting rid of that perpendicular, the distance is in the y. The reason why I got rid of that perpendicular is sometimes people write it like this, and it looks like it's the perpendicular distance to the y. And that's a problem, right? So we started out with perpendicular, and we said the moment about the x divided by the force that's in the z, and the d is going to be in the y. Okay? Daniel, would you give me the other equation?
Yeah, my
My over
fc.
f, which is still in the z,
So
and it's equal to d
the dx.
dx.
So that fz, that's your magnitude that you're
Well,
talking about?
I'm writing z small because we already found there's only one z.
Yeah.
And it's, there's only one force, resultant force, and it's in the z.
So if you had multiple ones, yeah.
You wouldn't have multiple ones in this problem.
Not in this problem, but
No, and not in a problem, this is already complicated enough, don't you think?
So
Don't go
the-
crazy thinking
so you're
about
saying the
another one.
homework is going to be like
The
that.
homework's gonna be like this.
Cool.
Okay, let's put in the numbers now. What's mx? So, David, we're up to you. What's mx?
Max is, I'll be keeping in meters.
Yeah, let's do
So
meters. 1250, it's negative, but remember,
The absolute value.
another important absolute value. And what's the force?
Force is
1400.
At all positives.
And then what's, David, do this one too, what's my?
It's 1050.
1050 over 1400. And what values do you get?
928.
This one?
I got one.
0.89
Yep.
Yeah,
inches? No,
meters.
meters. And what about this one?
0.75.
0.75 meters. Okay, I know I'm going over and I'll give you back points. I mean time. We can't put a positive or a negative in here yet because it was all positive because it's all absolute value. So now we have to figure out where it is. So let's take a look over here. So let's look at the moment about the x first. Is everybody with me? So when I dealt with the moment about x, I got a distance of 0.89, right? So the force is either to the left of the x or to the right of the x. Where is it?
Left.
Why?
The moment is going to be positive.
Okay, but is the moment of mx is actually negative,
Oh.
isn't it?
Yes. I'm so sorry. Yeah.
Right? So
Yeah.
look here. The moment about the x is negative. So is it in position A or is it in position B?
Okay.
If it's going down on the left side of x, it's going to create a positive moment about x. It's got to be in B. Okay, now let's look at y. We have position B and we have position C. Is it in B or C? The moment about the y is positive. It's got to be B. Okay, so I'm going to, it's got to be B. This can't be it. And what is it? What were the distances?
Maybe like 893.
Okay, so 890, and what's that distance in the y? This is another place people mess up. dy of 890, so let's say 890 millimeters and 750 millimeters. The dy is along the y. Remember that parallel rule. Here's the y. The distance along the y is 890, so it's around here, right? 0.89 meters. And the distance along the x is here, 0.75. So this is where that resultant force is, which is 1,400 newtons. So here's the perpendicular distance. I'm not going to write perpendicular distance. This represents my dy, the distance in the y, and this represents my distance in my x. I have an idea. Let's go back. Oh, any questions on this? Erin, you got a question? No. Anybody have a question? Oh, yeah. All right, let's look back at this.